Okay, so in the last video we studied about electric field at any axial point, and we got formula like this: 1 upon 4 pi epsilon naught 2 p r upon r square minus a square whole square p unit cap, means p cap. And after that we applied one condition in which we have taken that the distance of point P will be very large than the dipole length. In that case we can write formula like this: 2p upon r cube p cap. In this way we can write. So we got formula for electric field at any axial point. Today we will be getting formula electric field at any equatorial point, and this is the formula which we will be getting at last. So let us start deriving this formula. And in doing derivation, first of all we will study the diagram we are using for this derivation. So let us start here. In the previous case we have taken, again we have one dipole, again two charges are there, minus q and plus q. The distance between them is 2a. Half of this is a and other half will also be a in that case. Now in the last video, in the last lecture, you have seen at the axial point we have taken a point P here, which was lying on the axis of dipole, or along the axis of dipole it was lying. But this time the line is perpendicular to the dipole length. It is perpendicular to dipole length, and also one more thing, it is passing through the center of dipole. This type of line is known as equatorial line. And on this equatorial line we have a point, again same point P we are having at the same distance we have. Also along with this, let us discuss it also, this p cap. P cap is representing the direction of dipole movement, which is always, like we studied, minus q to plus q it will be. After this, at point P, first of all we will study electric field due to this charge, then due to this charge. After that we will calculate the net electric field exactly in the same manner like we used in the last video. After this, minus q, due to minus q, first of all let us see, you know that at point P you want to calculate. So assume yourself standing at point P and traffic is going towards minus charge. So this is the direction of electric field at P, which is represented by E minus q. And then again this is the direction of traffic. So at point P, what will be the direction? This will be the direction represented by E plus q. This electric field is due to plus q charge. After this, let us write their expressions. The expressions will be E plus q will be equals to 1 upon 4 pi epsilon naught q upon bp square. Now what is bp square? Bp square is the square of distance between point and the charge. So after this we can see bp cap. Now what is bp cap? Bp cap is the same direction along which E plus q will be lying. So actually this direction is represented here with the help of this cap unit vector only. After that, E minus q. Let us write electric field due to this minus q charge. Electric field due to minus q charge will be having same magnitude, like you can see. Don't go on this that these two things are different. Actually this BP and AP are same. This AP and BP are same. Reason, this line and these two parts are of same length. So using Pythagoras theorem, when you will calculate, you will get the same answer. So we can say here that the magnitude of these two vectors are equal. Here you just point out this AP cap. We have written AP cap, which represents direction in this way. Now as we studied that their magnitudes are equal, but you can see the directions are not same. Directions are different. One is going in this direction and the other is going in this direction. Two different directions we have of two vectors. Then to calculate resultant electric field using these two vectors in different directions, we will be using parallelogram law of vector addition. How can we do that? But we can do, but before that let us resolve these electric field vectors along horizontal and vertical directions. So how will we resolve? like this we will get the components along horizontal and vertical after doing resolution. So before resolution, I just want to point out here that if this is the triangular figure which you can see here, this triangular figure, right, this triangle I made here, this is the horizontal line and this is the vertical line, then okay, and one vector you can see here and the other vector is here, you have seen, then this angle and this angle, both I have taken equal to theta. These both angles will be equal to each other. Reason is, in front of these two angles the sides are same. Just studied that BP will be equals to AP. Now if this angle is theta, then the corresponding angle corresponding to this is this particular angle. This angle will also be equal to theta. And if you have seen that this angle is theta, then this angle will also be equal to this angle. Reason is, this black mark where I marked with the black pen, for this the reason is angles are interior opposite angles, and where I marked with the green pen, the reason for these two angles to be equal is corresponding angles. As you can see, this line and this line are parallel and this line will act as transversal. So I hope the angles are clear to you. This angle, this angle, this angle and this angle will be equal. So after this, if this angle was theta, then for this vector here cos theta component will come and here sin theta component will come. If this angle was theta, then for this vector in the same direction cos theta component will come and sin theta component will come along this direction. Now after this, you can see this we already studied that the magnitude of E plus Q and E minus Q is equal. After this you can see sin theta sin theta. Now we can say that the magnitude of whole of this is equal to this particular value, but you can see the direction is opposite. So that means this value will be going to cancel this value. That means the net electric field at point P will be only due to these Gauss components. So we will write here that net electric field will be due to only cos theta components. So these cos theta components you can see here in this how we have written this. We have written E vector is equals to E plus Q cos theta. Why? See here, E plus Q cos theta. After this minus P cap, then E minus Q cos theta. Look here, E minus Q cos theta, and again minus P cap. One thing is clear, that since both of them are in same direction, both are represented in the same way. Means the direction part is represented in the same way, minus P cap. Now why minus P cap? Let us understand this also. You have seen here that this was the direction of P cap, right? Then at point P, the direction of net electric field we have shown in this way, and we have seen that in the direction of net electric field only we have these Gauss components. That means the direction of E and the Gauss components will be same. The direction of E is like this, P cap is lying like this. P cap and E vector are in opposite direction, so we can say that this P cap for not P cap, for this E vector the direction will be represented by minus P cap. Minus P cap means opposite of P cap will be the direction of E vector, although there is some perpendicular distance between these two lines, but the direction remains same if it is here or you are calculating direction here. So it doesn't matter the distance between the two places, only the direction matters. The direction is this, which is opposite of P cap. Now Let us move ahead. So we reached here that net electric field will be due to these two components. So this minus sign here and here we have taken common and written outside. Then in the bracket we have E plus Q cos theta and E plus Q cos theta. But here you can see E minus Q we have written. In place of E minus Q we have written E plus Q. Reason you all know that the magnitudes are equal. Both have same magnitude, so we can write E plus Q in place of E minus Q. Now you can see this component and this component is very same, so 1 plus 1 will be equals to 2. So we have written 2 and E plus Q cos theta. After that P cap is also written with this, because we are writing the expression in vector form. Children, if you do not want to write in vector form, you can also write in scalar form, but in that case separately you have to tell about direction within bracket after that expression. So better is to write in vector form, to study in vector form only, because in the same way it is given in your NCERT. Now this 2 as it is written E plus Q. The magnitude is written over here. From where it has come from here. This was the magnitude, so we copied it here. Then the value of cos theta value is written here, A upon BP. Now what is A upon BP? You can see here this angle was theta, right? So with the help of this triangle we will be finding value of cos theta. Let us see how can we find out. This value is R, this value is A, this is angle theta, this is B, this is P, and this is O. Right, so from here the value of cos theta will be equals to, cos theta is base upon hypotenuse. You can see base is A, so A we have written, and hypotenuse is BP, so BP is written. Like this we can find out the value of cos theta. Then the value of cos theta is written here, A upon BP. Now this BP square and BP gives us BP cube and QA, and this 2 we have written like this, Q into 2A minus 1 upon 4 pi epsilon naught, in the same way it is written, and also P cap. Now this Q into 2A gives us capital P, which is again dipole moment, and here in place of BP you can see this BP cube, this value is written here. So how we got this value? We got this value with the help of Pythagoras theorem. If I would be able to show you, see, this was R, this is O, this is point P, and this is B, right? And this distance was A. Now if you will apply here Pythagoras theorem, then using Pythagoras theorem we will get result R square plus A square in square root, right? Writing in square root, we can say we are writing this whole quantity to the power 1 upon 2, correct? Now because it was not BP only, it was BP cube, so in while writing BP cube, what we will do? We will do cube of this whole expression. So while doing cube, this power 1 upon 2 will be multiplied by 3. So when it will be multiplied by 3, what will come? It will come 3 upon 2. So like this we have written, in place of BP cube we have written this R square plus A square to the power 3 upon 2, and we got our final expression. This is semi-final expression you can say, because after this we are going to apply condition that if the distance of point P will be very large than the dipole length, in that case these these assumptions we can make here, and it becomes equal to R cube only at last. So this is the final expression we can say here. So what is the difference as compared to the axial point electric field? No minus was there, here we have one minus. There it was 2p, here we have p. These two only are the differences, otherwise the result is same. So In this video we studied this derivation only. Next time we will study dipole moment in external electric field.